I hope
Yes, yes.
that's good. So we are going to discuss among the crucial topics in paper 2, physics, current electricity 2. Electricity 2, uh, we have two current electricity 1 in form 1, and that's known as simple cells and simple circuit. And this is number current electricity 2 in form 3. So it is a very common question in very common topic in paper 2, and it usually covers 10 marks, 10 to 13 marks in paper 2, section B or section 2. So work with me as I navigate this topic. So electric current, the current it's denoted in physics as I, and the potential difference as V. So electric current is the rate of the flow of charge through a conductor, through a conductor. And the moment in physics you hear something that's known as rate or anything to do with rate, is something multiplied by time. So meaning that current that is denoted as I, current denoted as I is equals to the rate of flow of charge. So that's the charge that is written as Q divided by time. Time. So the rate inamaanisha nini divided by anything to do with divide by time. It is measured, current is usually measured in ammeter, using ammeter, and voltage is usually measured using a voltmeter. So it's a very important instrument for you to know, and it's a very common instrument that they are usually used in physics paper 3. Also current electricity, it usually comes in paper 3 equivalent almost 20 marks, equivalent 20 marks. So you understand it is a very important topic. So that's number one. Electric current, we say that's the rate of the flow of charge through a conductor. Potential differences is work done in moving unit charge between 2 points in a circuit. That's known as potential differences. And it's measured using voltmeter, and it's measured using volts. An ammeter, the SI unit of ammeter is ampere. Is ampere. So voltmeter is when the circuit is closed. When the circuit is closed, anything that is used or any charge that is used between the point or any energy that is used between the point inaitwa nini? Ndio zinaitwa the potential differences. That's why potential differences inafanya work done divided by the charge moved in coulomb. So that's the work done in joules. In joules, that's the energy divided by the charge moved. So voltmeter is equals to W over Q, which is equals to W is equals to QV. So that's the this formula naturally came from the current electricity 1. That's the cells and simple circuit. So it is very important for you to capture that. Example 1 is in a moving charge of 10 coulomb. Coulomb is a Q, is a charge. So Q we have 10. From point B, when 20 joules of work is done. So that's the work done. So when 20 is the W, What is the potential differences? What is the potential difference? So wanatuliza nini? The W. W is equals to QV. W is equals to W is equals to QV. Na saizi wanatuliza nini? The potential differences. That's a V, I mean. That's a V. And V is the potential difference. Inafanywa aje? Inafanywa work done divided by the charge. That's a Q. So itakuwa ngapi? Itakuwa 120 divided by 10. 120 divided by 10. And it will be 12 volt. 12 volt. Eh,
معلم.
yes. In form 1, we see that ammeter is connected across along the component, yani in series, while the voltmeter is connected across our component, yani in parallel. So explain why ammeter is connected in series and the voltmeter is connected as parallel. The reason is ammeter, it has low resistance, while voltmeter, it has high resistance, because the moment the voltmeter is connected here, the charge that is moving ikiingia hapa, it will resist to flow. it will reach to full load. That's the reason. So also this is another important part. When the component is connected in series, so in this topic we only learn three things. We learn three things. That's the I, that's the I, that's the current, volt for voltmeter, and the resistance, So this topic actually covers these three things. The moment you know these three, almost you know 95% of the marks you have it. So when the components are connected in series, the I total, yani all the current, total current inafanywa aje? Inafanya is equals to the I1 is equals to the I2 is equals to the I3, meaning that if you have a current of 20 ampere, the total current will be 20 ampere, so meaning that they are equal. But when you are asked the voltage of the current of the component that is connected in series, when you asked the voltage of a component that are connected in series, you add the voltage. So V total will be V1 plus V2 plus V3 equivalent. When the component is connected in parallel, it will be opposite then. It will be opposite. The current I total will be I1 plus I2 plus I3 equivalent level. But when we are in voltage V total is equals to V1 is equals to V2 is equals to V3. And that is when the components are parallel. Because voltage is connected across the component. It's connected in parallel, yeah. So that's the formula that you have to know. So the only formula that you have to master when you're in current, electricity, that's three. Number one is when we are talking about current. Number two, when we are talking about voltage. And number three, when we are talking about resistance. Resistance. So resistance tafikia, but then all of these three, we are dealing only two things. That's number one, the series one and the parallel one. The series and the parallel. So when the component that is connected in series, you have to know the formula of I, how to find the I total, how to find the V total, how to find the R total. When the component is also connected in parallel, you're supposed to know when the current is how to find the current, how to find the V total, and how to find the R total. But I advise my student to stick with one only. And the other one will automatically be opposite. Najua hii kitu kama hii huwa confuses a student a lot. So as my student huwa anasema, just stick with series peke yake ama parallel peke yake. So stick with that. The moment you stick with parallel, the series will be opposite of the parallel. Or the moment you stick series, the series will be opposite of parallel. Look at this. I total is equals to I1 is equals to I1 is equals to I3. That's when we are talking in series. That's for I. But when you are connected in parallel, it is opposite. You add it. Look at the V total. Got V1 plus V2 plus V3. But when it is parallel, look at it. It will be opposite. So it's up to you. So let's do this example. Find the current through L1. So walituambia tu the current through L1. Given that 0.8 A passes through the battery. So 0.8 inapitia nini through the battery. So we say that A, the moment you hear the A stands for ampere, and the ampere is the SI unit for current, and the current is written as I through the battery of 0.2 ampere through L2, 0.5 ampere through L3. So meaning that, look at this, all of these are connected in parallel. Parallel unajua either inaconnectiwa hivi or inaconnectiwa hivi, lakini series it is across, it's not across. Series where we connect is alongside. We connect along. So tunaweza connect volt hapa ama ammeter hapa, ampere hapa, ingine hapa. so we cannot across within one line, lakini hizi ni line tofauti tofauti. Nikiweka hivi, moja naweza weka hapa, ingine niweke hapa, ingine niweke hapa, ama niweke hivi. So for example, this in this component it is parallel, it is parallel. So what are we tunaulizwa nini sasa? Find the current passing L1. So tunaulizwa L1, tuko na L2 na tuko na L3. Then the current here across is the total current. The current here is the total current. So when we are in current, the cell is connected in parallel, or the component is connected in parallel, how do we do it? The formula is I total is equals to I1 plus I2 plus I3. So this is the formula. So you say that 0.8, which is the total, is equals to I1, which is tafuta, plus I2 0.28 plus 0.15. So after that, this 0.43 plus I1 0.8. So then 0.8 minus 0.43 is equals to I1, and I1 will be 0.37 ampere. 0.37 ampere, and that's how you find it. So that's the difference between the when we are talking about parallel and when we are talking about in series. When I'm talking about series. I think I'm clear with this question. Because and I know we're going to come across a lot of questions. And I think that is very important is Ohm's law. And Ohm's law, they will tell you in exam situation to state it. So how do we verify the Ohm's law? This is a rheostat, this is a voltmeter, this is a ammeter, and these are resistors. So the rheostat, kazi yake ni you just adjust it so that minimum current is recorded by ammeter. So you adjust to make sure that the minimum current is recorded by the ammeter here. So the current is then verified in steps using rheostat, and the corresponding voltmeter reading is recorded. This is repeated several times. The results are tabulated. Tabulated meaning a table of voltage and current. Then a graph is plotted of voltage against current. So we plot a graph of voltage against I. And the moment we plot a graph like this, we get a straight line graph. And this straight line graph, and this is how the Ohm's law is verified. And then in exam situation utakwambia nini, especially in paper 2, state the Ohm's law. Ohm's law states that the current flowing through the conductor, the current, so now this is a voltage and this is a current, so they are directly proportional. So you see that it states that the current flowing through a conductor is directly proportional to the potential differences, and the potential difference is voltage, provided that the temperature and other physical conditions are kept constant. These must be kept constant. The moment you omit that word, I don't know what will happen to you. So very important for you to know that. So when I get the slope of this curve, slope is the gradient of this curve, ambayo iko na voltage, na iko na I, that's the current. I mean a straight line, I get their slope. When I get the slope will be resistance. So and resistance is the ohms. So gradient itakuwa sana nini, change in V. So this will be change in V over change in I. That's a constant. And the constant is the resistance ohm. And ohm is denoted as this. So whatever that you will get will be, for example, it will be 20 ohms, 30 ohms, yeah. So acha sasa hii kitu sasa nikufunze practically. These ohms law also can be tested in practical. So when you are in practical, number one, tables. When you are filling the table must be having constant decimal places. For example, if this is a volt and this is a I, this is a I, so this, for example, these are 10, 10.0 or 10.1, 10.9, yani, I mean, if you take one decimal places, all of them must be one decimal places. All of them must be one decimal places, because that is, the table must be, the decimal places of the table must be uniform. Must be uniform. That's the number one thing that you have to know. So in question, sometimes there is a letter EV, a current of 2 milliammeter. So another thing about you have to know about physics is that in generally it is in physics. Physics is a two words. Huwa watoto wana confuse, but these are this capital M and this is small m. This capital M means mega, and it's usually 10 raised power 6, 10 raised power 6, and this is small m power 3, power negative 3, I mean, this is power negative 3, power negative 6, sorry, yeah, this is power negative 3, it's usually 10 raised power negative 3. So let's go to this question. We're going to understand through this question. A current of 2 milliampere, 2 milliampere, meaning that the 2 times 10 raised power negative 3 times 10 raised power negative 3. 10 raised power negative 3 now 2 divided by 1000. 2 divided by 1000 flows through a conductor resistance of 2 kilowatt. 2 kilowatt. Calculate the voltage across the conductor. So what do I have? I have the voltmeter, and I have the resistance, because the resistance is the ohms and andiko hivi. So the formula is this for resistance: V over I is equals to R. Na hii formula na huwa wanaitanga nini? V is equals to IR. V is equals to IR. This is the general formula. V is equals to IR. V is equals to IR. So what will happen is the voltmeter hatuna, because watuambia calculate the voltage, sio? Hatuna. The I tuko naye, I ni 2 times 10 raised power negative 3 times ampere. Kilo ni 10 raised power 3. Itakuwa ngapi? Itakuwa 2 times 10 raised power 3, which is 2 times 1000. 2 times 10 raised power 3. 10 raised power 3. 10 raised power 3. So this 3 and this 3 zinaenda. So it will be 2 times 2, itakuwa nini? Itakuwa 4 volts. So hapa itakuwa aje? Nimekuambia mega will be 10 power 6. Mega will be 10 power 6. Milli will be 10 power negative 3. Kilo will be 10 power 3. Kilo will be 10 power 3. Kilo will be 10 power 3. So hivyo unafaa ujue. So this question of ohm sometimes unaweza test ikwa Drimax, ama sometimes unaweza kuletea ikwa swali mrefu. Sorry?
Excuse me, pardon that question, Malim.
This question, yeah, I will repeat it. Thank you.
Yes.
I will repeat it. So these questions of current electricity, they may be tested only 3 marks like this, or they may be tested in section 2 equal 13 marks. But nowadays physics is changing. If you look at KCC 2024 and KCC 2025, they are so similar, meaning that naturally physics paper 2 part B zinafaa zikuwe na calculation mingi sana, especially ya 13 marks, 12 marks and 10 marks. Huwa hata hakunanga na 10 marks, mostly nakuwa na 13 marks, 15 marks hizo. But nowadays na zote zikuwe calculation, but nowadays especially 2024, yani unaona tu ni 3 marks peke yake ndio calculation, zote ni theory. Then KCC 2025, I was expecting KCC 2025 to be the physics paper 2 to be calculation zote, but the moment I saw the paper, I was astonished. So let me repeat this question. First of all, the general formula is V is equals to IR. V is equals to IR. You have to understand that. That's the first formula. The formula is V is equals to IR. Hii formula usiwahi sawa, because itakusaidia mahali mingi sana. V is equals to IR. So tusome question. A current of 2 milliampere. So already umetuambia a current. So that's the I. So I will be 2 milliampere. 2 milliampere. And I say that in physics there are two things, milli and mega. Mega is 10 raised power 6. Mega is 10 raised power 6. Milli is 10 raised power negative 3. 10 raised power negative 3. So I say that a current of 2 milliampere, meaning that milliampere is 2 times 10 raised power negative 3 ampere. Not why your milli, 10 raised power 3 ampere. That's our current. Flows through a conductor of resistance 2 kilo ohms. I say that the SI unit for resistance is ohms. So the resistance is 2 kilo ohms. So the resistance R is 2 kilo ohms, which is 2 times 10 raised power 3. 10 raised power 3. That's a kilo. Kilo is 10 raised power 3. Calculate the voltage across the resistance. So voltage is equals to V is equals to IR. So we just multiply these two figures. So when I multiply these two figures, let me wrap it. So the moment I multiply these two figures, that is 2 times 10 raised power negative 3 times 2 times 10 raised power 3. 10 raised power 3. So I will multiply these two. So unaweka tu calculator yako na upate answer yako. Unaweka calculator na upate answer yako 4 volt. Ama ufanye aje? Ufanye hapa ni 10 raised power negative 3 sio? So 10 raised power negative 3 negative inamaanisha divide by 1000. So hii inamaanisha divide by 1000. So hii inamaanisha divide by 1000 tukifuta hii, then hii pia ni 1000 tu. Ni 1000. Hii 3 tufute. So hii ina cancel na hii. So itakuwa 2 times 2 which is 4 volt. Yes my boy, are you okay?
Yeah.
You are okay. So can you mute yourself please? Mute yourself. So another thing ambayo tunafaa tuangalie ni ohmic and non-ohmic conductor. Ohmic conductor are conductors that obey Ohm's law. And Ohm's law inamaanisha nini? Ohm's law ni simple tu. Ohm's law ni whenever that I have the current, whenever that I have the current and I have the voltage, the graph that I will obtain must be straight line, meaning that the conductors, the voltage and the current are directly proportional, and that's known as ohmic conductors. So whatever that their voltage and their current have a same or directly proportional, are said to be ohmic conductors. So ohmic conductors are conductors that obeys Ohm law. That is, voltage across is directly proportional to its current, e.g. metal like nichrome or electrolyte like copper sulfate. Non-ohmic conductors are material whose graph of current against voltage is not a straight line, or material whose resistance changes with the current flow, e.g. torch bulb, thermistor, because torch bulb the moment unatumia ina reduce, the moment unatumia sasa nini, the current hiyo ina reduce sasa the light. For example, saa hizi torch iko mpya na iko full, lakini the moment you use it inaanza kuwa dim. So the current sasa, the material whose resistance changes with current flow. So as the moment current ina flow, the resistance ina increase. So inakupatiana graph kama hii sasa. So sometimes especially in local exams unaweza kuambia nini, differentiate between ohmic and non-ohmic conductors. Especially in local exams. Another thing about you have to look at is electrical resistance. Resistance as the name itself suggests. Nasema resistance ni kukataa tu, kitu kukataa, inakataa. So resistance ni opposition offered by the conductor to flow electric current. So this conductor ambaye that I have, the opposition that it offers ili ikatae this current ipite, ndio zinaitwa ni electrical resistance. So there's a factors that affect electrical resistance. So What does that affect electrical resistance of a metallic conductor, which is very common question. Very common question. Very common question. These are very common question. I repeat it. So factors number one is temperature. Factors number one is temperature. So heating, this temperature increases energy because heating increases the kinetic energy of an atom, making them to vibrate more. This increases the collision of particles. It increases the collision of particles. So the moment it increases the collision of particles, per cross-section area of the conductor, the opposition of the to the workflow of electron dust increases. Hence, an increase in temperature increases the resistance of the metallic conductor. However, this does not mean that the resistance of a metallic conductor, e.g., copper, can fall to zero at extremely low temperature. So first of all, kitu muhimu sana, sometimes naweza kwambia we explain lakini how temperature affect. Number one, the moment you increase the temperature, it increases the kinetic energy of atoms. So the moment it increases that energy, it makes the particles to vibrate more. So this increases the collision answer, because these are particles, and whatever that we have here is electrons. It's electrons. So they vibrate sasa. They vibrated. So the collision increase. And the moment the collision increase, the resistance also increases. That's temperature. Number two is the length. Resistance R of a uniform conductor is given material is directly proportional to it is L. So meaning that resistance is directly proportional to its length. Meaning that if the length is kama length ni kubwa, the resistance pia itakuwa kubwa. Cross-sectional area meaning that for example kama moja ni mfupi, moja nikirudia hii ya length, moja ni mfupi na mwingine ni mrefu, so meaning that huyu akona this will be, it has low resistance, huyu mwingine akona high resistance. Number three is cross-sectional area. This is also a very important part. Cross-sectional area, a conductor with light cross-sectional area has many free electrons, hence better conductivity or low resistance. By the way, that's naturally. The moment hata hizi charger ama hizi cables tunatumianga, the moment the cable inakuwa kubwa, the more the current can pass it. So itakuwa na low resistance. So sometimes that's why most of them sometimes inaweza kuwa inaharibika haraka. So the low current, a lot of current inapita, a lot of, because ni kubwa sana, it is very thick, concentration liko high sana, na huwa inatafutwa aje? Tunasema the resistance is inversely proportional to the cross-sectional area. So these are two equations that we combine. Number one is this, R is equals to R is directly proportional to L, and these are R is directly proportional to L and it is inversely proportional to A. And the moment after we combine it, we get something that's known as resistivity. Resistivity is denoted as P, P, inverted P. And so this resistivity is equals to RA, that's the resistance and the area, divided by the length. Very important for you to capture this. Find a lot of questions na utaelewa. A wire for 80 centimeter cubic, that's for 80 centimeter long, that's the length. So length, I have the L ni for 80 centimeter, length ni for 80 centimeter, diameter of 0.56 millimeter. So I have the diameter 0.56 millimeter. If the resistance of the wire is 10 ohm, so I have the resistance of the wire as 10 ohm. Calculate the resistivity. So resistivity will be RA, that's the resistance. The formula is R times the area divided by the length. and this area depend on whatever that you have it. For example, this is a wire. Wire area yake inatafutwa aje? Pi r squared. The pi r squared. So before you do anything, I highly advise my student to convert any unit that you have into its SI unit. That's my advice, but you can continue it directly, lakini ukicontinue directly huwa inasumbana sana. So convert it all of them to their SI unit, whatever you have. For example, this centimeter, the SI unit of this centimeter is meter, so it will be for 80 to the 100, and I will get 4.8 meter. 4.8 meter. Wait, 4.8 meter. The ohms ni 10 ohm tu hii unit yake iko sawa. 0.56 millimeter, this is the diameter. Umesahau diameter, it will be 0.56 by 1000 by 1000 and will be, even this is the diameter, I can say the 2 ili nipate radius because nahitaji 2 radius, so it will be 0.28 by 1000, and I will get 0 point as my radius. Radius will be 0.00028. So I will just follow the formula. So resistivity is equals to resistance, that's a 10, times the area, that is a pi r squared. So just use the pi that's in calculator. You can just use the pi that's in calculator, because in rules, when marking physics or anything that and mathematics, we say that if you are not given the pi to use the pi that is provided in the calculator. So it will be pi times r 0.00028 pi r squared. This is also use square, divide by L, and our L is 4.8. So ukifika hapa you have almost, kama ni 3 marks, you have almost 2 marks. So after that you get your answer. You just, sasa ukifika hapa hata usi simplify, don't simplify it further, just put it this figure to calculator and get the answer. And the moment you put the answer, you will get 5.32 times 10 raised power negative 7 ohm meter. Ujue, because the SI unit of the resistivity is ohm meter. So it is ohm meter. In physics, when you are marking physics, we say that if you don't know the unit, achana, usiandike kitu yote. You only lose a half marks. But the moment you commit yourself to write another unit that is wrong, for example, mali ya meter umeandika kitu kama centimeter ama meter, you will lose all the marks. So make sure that in physics ni hivyo tu, kama unajua marks na kama unajua the SI unit, andika. Kama hujui hiyo, achana, you only lose half marks. And a half marks in exam ni mingi sana. So that is the resistivity. So just follow the formula as a resistivity. So before sijaenda equation for resistance, is there any question? Salam, kuna swali? I said tuko sawa. Oh, so that's good. Let me go another part. That's the resistance. Now resistance iko very muhimu sana, very important. Number one, I say that this topic, these are 3 main parts that we are covering, and that's the 3 main confusing part. Hizi zingine just ni kusoma tu na unasoma. Number one is, I say that that's the I, that's the V and R. That's the I for current, V for voltage, and R for resistance. I say that all of these I, V, and R, you have to know how to do it when the component is in parallel or in series. And I also told you that I advise my student to stick only one. You can stick either parallel or you can stick either series, and the other one will be opposite of that. Will be opposite of that. So kuja kwa resistor. So resistor is a material designed to offer some resistance. So this material, but they offer any resistance. So for example, ni kama tungsten thermostars and constant alloys. So there are two types of resistance. These are fixed resistors. Fixed resistors are resistors designed to give a fixed amount of resistance, like of carbon resistors, resistors, the wire round resistors. So they are just designed to give a fixed amount of, for example, kama ni resist 2, they have to resist that 2 ohm, 2 ohm. Kama ni 2 ohm, kama ni 3 ohm. So they are designed to to give a fixed amount of resistance. Number 2 is the variable resistors. A resistor designed to offer a very range of resistance. Like kama rheostat. Rheostat unaweza manipulate ili kupatia nini a different, you can control it using the knob on the radius, so you can control it. So ukifikisha hapa kuna some amount na unakata, ukifikisha hapa inakata some of the amount, so depending on the magnification. Also kuna potentiometer. These are three terminal variable resistors. It is used to balance control in audio amplifiers. Non-linear resistors, current flowing through this resistance does not change linearly with change in applied voltage. So they don't change linearly as the voltage changes. The more is the thermistor, it's used to its temperature depend on the resistors. Its resistance decreases with increase in temperature. Number 2 is the light dependent resistance. The resistance of an light dependent resistance decreases when it receives light. When it receives light from the sun or any other place, it decreases as it receives light intensity. So it's used in light operating switching circuit. So measurement of the resistance. So how do we measure the resistance? We measure, number 1, using voltmeter method. So we have the voltmeter and ammeter. We adjust the variable resistance with switch close. So this switch is closed, switch is closed. Then this rheostat is adjusted in a songesho. Then as in a songesho, tunaangalia nini the reading in ammeter and the reading in voltmeter, and we tabulate it. We tabulate inamaanisha nini? Tunachora table. So kuchora table na tunachora graph and that's how we measure resistance ya kwanza. Ya pili ni using a Whitestone bridge method. When the Whitestone bridge is at balance, no current flows. So when this Whitestone bridge is at balance, there's no current flows through the galvanometer. Hence, there's no deflection of the galvanometer. So we use a meter bridge method. We adjust the position of the B. Until there's no deflection of the galvanometer. This is a galvanometer. Galvanometer is written as letter G. This is a galvanometer. So we just tutna endelea sasa until there's no resistance. So the resistor network, sasa hapa ndo tumeingia mahali muhimu sana. When the resistors are connected end to end, same current flows through each resistors, i.e. I total is equals to I1 is equals to I2 is equals to I3. Potential difference across each resistors is different. So that P total is equals to, so meaning that this is series. This is in series. And R total is equals to R1 plus R2 plus R3. Even on whole J2. For series, I is equals to I total is equals to I is the same too. So for example, come hapa tukona 20 ampere. The total I will be 20. Potential differences, we just add all these, and R total we add all the R's, R1, all the resistance yani. Look at this question. The figure below shows a resistance in series connected in a power source. Current in 2 ampere, these are 2 ampere, was passed. Calculate the voltage. So we voltage is a V total. So you add all the V's. v. So how do we add all the v's? We add all the v's, so itakuwa v is equals to ir. V is equals to ir, so itakuwa v is equals to ir. Sawa? So v is equals to ir, so this will be 2 times 2, so that will be 4. The first one itakuwa 4. This is the I. Hii I no, they share all of them. So this will be 2 times 2 itakuwa 4 plus 2 times 6 will be 12. 2 times 8 will be 16. So you add all of it. That's all. That is 16 plus 12 plus 4, and you get 32. So hiyo umetuambia nini? Swali kwanza umetuambia calculate the voltage drop across each resistor. Resistor 1, for example, hii ya voltage ya kwanza will be 2 times 2 itakuwa 4 volt. Ya pili it will be 12 volt because itakuwa 2 times 6. Mbona tunatumia 2? Because when we are in series, all the current are same. I total is equals to I1 is equals to I2 is equals to I3 hivyo. So that's number 1. Number 2 is the voltage across the source. Ukituambia ni V total. Sasa inamaanisha nini? You add all these V. So it will be plus 12 itakuwa 16 plus 16 itakuwa 32. Tumemaliza. The second question is the total resistance. Resistance will be 2 plus 6 plus 8. You add the resistance. So you just know here, you just know the formula, nothing else. You just know the formula and it's that simple. When the current is connected in parallel, sasa itakuwa opposite. For example, kama umeamua ustick na hii, nimekwambia I, kama hapa I is equals to here I total. So umetuambia I total is equals to I1. So hii pia yasa wakati iko in parallel itakuwa opposite of this. So opposite of this itakuwa ngapi? Kama hapa ni I total is equals to I1 is equals to I2 0. So this will be I1 plus I2 iko inaendelea hivyo. So it will be going in. So tukuje kwa V. Hapa tuna add V zio, V total is equals to V1 plus V2 zio. So hapa kwa parallel tunaanza aje? Tunaanza V total is equals to V1 is equals to V1. So V are same. So kwa parallel V are same. So they are same. Tukuje kwa resistance. Sasa hapa ni R total is equals to R1 plus R2 plus R3 sio? So hapa R total inafanya aje? R total is equals to 1 over R1. Hapo sasa hii tunasema 1 over R1 plus 1 over R2 equal inaendelea hivyo. R2 and going forward inaendelea hivyo. So that's how we do it. So resistance content in parallel. So na I total is equals to I1 plus I2 plus I3. Tulisema hivyo. Then tukuje kwa V. V total is equals to V1 is equals to, so V are the same. Tukuje kwa R itakuwa 1 over RT is equals to 1 over R1 plus 1 over R2. Hivyo. Tukuje tufanye example. A circuit below shows for 4 resistance connected in 3 volt supply. Calculate the effective resistance. So effective resistance in all resistance. So it will be 1 over 2. It will be 1 over 2 plus 1 over 6 plus 1 over 8 plus 1 over 10. So I will plus 1 over 10. Na hapa sasa unafaa ukuwe careful kabisa. So you will get ngapi? 107 over 120. Whatever you got ndio unasema aje? Unasema reciprocal. So utakuwa nini? 120 divided by 107 and you will get 1.121 ohms. Finally, when we are dealing with parallel, you say 1 over plus 1 over. After you got the result, you reciprocate the result. Please don't forget that. Whatever the figure ambayo utapata hapa unafanya reciprocal and you get the answer. Number 2 is the current through the 8 ampere. The current through the 8 ampere. Since sasa hapa current itakuwa I1 plus I2 plus I3. So total current tuko nayo hapa. Tuko na total current here, yes. A circuit below shows a resistance of current across the 3 volt. So tuko na voltage. Tuko na voltage. So nakuja sasa nasema V is equals to IR. V is equals to IR. So natafuta nini? I sio. Nasema divided by R, divided by R, divided by R, divided by R. So I itakuwa V over R. So V, they share all the V, that's a 3, divide by, sasa nachukua R ya peke yake, R ya 8 peke yake sasa. R ya 8 peke yake. So divided 8. So V divided 8 and it will be 0.375. 375. So in parallel, volt are the same. In parallel, volt are the same. In series, current are the same. In series, current are the same. Kuna swali lolote after here? Is there a question? Let me look. Absalam, uko sawa? Absalam, naona Asada kwa sawa. Now are you okay? Or do you have any other question? So that is all about in parallel series. So sometimes kwa mtihani they combine it. Hata we combine, still you have to follow the formula. Sometimes there's another formula that they used to follow, little bit different, but I usually tell my student that just follow our formula. Look at this. Calculate the effective resistance for circuit below. Ya kwanza ni hapa ni 19, hapa ni 30 na hapa ni 70. Meaning that hii ni series. These are series and these two are parallel. So malizana na hizi parallel kwanza. Hizi parallel kwa nafanya aje 1 over sio. So it will be 1 over 30. It will be 1 over 30. 1 over 30 plus 1 over 70. 1 over 70. 1 over 70. 1 over 70. You get 1 over 21. You get 1 over. You get 1 over 21? Yeah. You get 1 over 21. If I'm not wrong, yeah, you get 1 over 21. 1 over 21. So ilikuwa nini sasa? Tulikuwa tunasema in parallel tumepata answer yako, you reciprocate, unafanya reciprocal. So 1 over 21 reciprocal yake ni ngapi? Ni 21. Ni 21. So hiyo 21 umepata ndo unaanza sa 19 plus 19 plus 19 and answer becomes 40 ohms. 40 ohms. Ndivyo tu. Look at this. Tuangalie yote. Calculate the equivalent resistance of the circuit. Meaning that these are series, these also are series, but hizi mbili and hizi mbili are parallel. So tumalizana na hizo mbili. Wachana hii wachana tumalizana na hii. So easy to add hizo zote itakuwa 5 because they are series. Itakuwa 5 plus 7 itakuwa ngapi? Itakuwa 12. So tumalizana hizi itakuwa 1 over 12 plus 1 over 8. 1 over 12 plus 1 over 8. So unasema 1 over 12 plus 1 over 8, I will get 5 over 24. Ilikuwa nini? Tulikuwa tunasema aje? Tulikuwa tunasema the moment you got the result, you reciprocate. That's a 24 over 5 and you get 4.8 ohms. So this 4.8 ohms ndo una add sasa 4 plus 4. You just add 4 plus 4 and you get 8.8 ohms. Ndivyo tu. Malizana tu ile ya parallel. After umemalizana ya parallel, reciprocate. That reciprocal, you add the series one. Hivyo tu. Let's go. The resistance hii ni current, hii ni parallel. Nataka ikuwe combine. Yeah. Use the circuit diagram below to determine the effective resistance. So resistance ni total resistance, ndivyo. So first of all tuna malizana hizi sasa. Malizana hizi itakuwa 1 over 6. It will be 1 over 6 plus 1 over 3 plus 1 over 6. So itakuwa 1 over 6 plus 1 over 3 plus 1 over 6. Tutapata ngapi? 2 over 3. These 2 over 3 we reciprocate sasa. Itakuwa 3 over 2, itakuwa 1.5. This 1.5 I add 2.5 sasa, then I add 2.5 and I get 4 ohms. Nimemaliza 3 max hivyo. The second question, the current through the 3 ohm resistance. So I need the current through the 3 ohm resistance. So this is the formulas for series and for parallel. For series, I1 is equals to I2, but for parallel itakuwa opposite. V total itakuwa V1 plus V2, but for parallel itakuwa opposite. Total itakuwa R1 plus R2. So this is the formula ambayo unafaa ushike. So tukifanya hiyo swali ya the total determine the current through the 3 ohm resistance. Current through the 3 ohm resistance. Where the 3 ohm resistance. So we know that V is equals to IR. V is equals to IR. We know that V is equals to IR. And V, so tunatafuta current sio? So I itakuwa V over R. I will be V over R. V over R. So nikitafuta total current because hii iko kwa parallel sio? Nikitafuta total current itakuwa aje? Total current itakuwa I is equals to I2 plus is equals to V over R. That's a 2 divided by 4. Bwana anasema 4 because the total resistance that we have is 4. So itakuwa 2 divided by 4. So, and I will get 0.5 ampere. 0.5 ampere. 0.5 ampere. So since nimepata 0.5 ampere, hiyo 0.5 ampere ni current ya hii circuit zote. So hii circuit sasa, hii circuit ina contain kitu mbili. Number 1 ina contain parallel na ina contain nini? Na contain series. So natafuta ya series peke yake. Wacha nitoe ya series. So it will be V is equals to IR sio? Itakuwa sasa 0.5 times 2.5. So and I will get 1.25. I will get 1.25. That's for I peke yake. That's for series peke yake. So I got already niko na ngapi? Niko na ya series. So what can I do then? So voltage tulikuwa na voltage ya mbeleni tulikuwa na 2 volt. Saizi ya series niko na 1 volt. So V total ya series it will be V1 plus V2. That is 1.25 from here. 1.25 from here plus V ambaye tunatafuta 1.5 ohm. 1.5 ohm. So after that we shall get 0.375 divided by 3 and we will get 0.25 as our answer. And this tunapata aje? Tunasema this is the total. Hii ndio ya series peke yake sio 1.25. And the total ambayo tulikuwa nayo ni 2. So it will be 2 minus 1.25. I will get 0.75 volt. So hii voltage ya 0.75 volt zote ni ya nani? Ni ya parallel peke yake. Because nimetoa ya series. So since nimeuliza a current through the 3 ampere, it will be 0.75 divided by 3 and I will get 0.25 ampere. Simple. Nikirudia nimesema the first answer I got 4 ampere. The 4 ampere nimepata ni ya watu wawili. Number 1 ya series hizi tatu. Let me change my pen. This. So ni ya series hizi tatu plus ya parallel hizi tatu, hii ni parallel tatu I mean, na hizi series ya moja na hizo zote. So what do I do? I will only find the voltmeter of this only. And I say V is equals to IR sasa. Nasema V is equals to IR. So since natafuta voltage I ni ngapi? I will say that our I will be where is our I? Yeah, we are going to find our I as 2 over 4. 2 over the 2 is the voltage, total voltage, therefore I will get our I. This I will be 0.5. So nikiwa niko na hii I, naweza tafuta za V of the voltage of this only, the voltage of this only. So V is equals to IR. Our I will be 0.5 times R, the resistance of that only. As a resistance of this, that's the 2.5, and I will get 1.25. I will get 1.25. This 1.25 ni nani sasa? Ni ya series peke yake, so I minus from 2 because total voltage ambayo tulikuwa naye ni 2, so hii ni 2 ndio tulikuwa naye total. Kwa 2 minus itakuwa ngapi sasa? The answer will be 0.75 volt. So let's say we tuliza nini? The current through the 3 ampere, sasa 3 resistors. So 3 resistors ni, so I say that current I is equals to V over R, and our V will be 0.75, ile remaining 0.75, because bwana tunasema tunachukua hii 0.75 na ni zote because in parallel they share the V's. So V total is equals to V1 is equals to V2. So V is the same too, equal constant. So itakuwa divided by R, which is 2.5, then and I will get the answer. As 0.25 ampere. So this question unafanya to the same, and that's all about current electricity 2. So these are electromotive force and internal resistance in EMF and internal resistance, that's the EMF, electromotive force and terminal voltage. So ile kitu tunapata juu hapa ni this formula, E is equals to, that's the EMF is equals to IR plus IR. Sometimes sasa hii IR inamaanisha nilikuwa nakwambia nini, V is equals to IR, sio kwa huko mbeleni, V is equals to IR. So since V is equals to IR, badala tuandike IR tunaweza andika nini? Tunaweza andika V. That's why nimeandika nini? E is equals to V plus IR. Or unaweza sema aje, hii E is equals to IR plus IR, sio I is common, so nasema E, that's the electromotive force, is equals to I, this is a common, I can factor that I uko hiyo ya nje na niseme nini? Plus R. Zote ni the same. So badala easy formula iko confused, just chukua tu hii peke yake, itakusafe. So E is equals to IR, that's the capital R plus IR small r. So to determine the internal resistance, you connect the apparatus as shown below, then unachora nini, you tabulate it. After tabulating, you just unatafuta nini, unatafuta the slope, because hii slope kwa inakuwa y is equals to, in form of y is equals to mx plus c, and hii tunapata aje? V, so our V sasa ndo tunapata our V plus IR, so sasa since hii V ndo y axis, unajua V ndo y axis na hii y ni x axis, so nasema aje? Y is equals to mx plus c, so nini ina act kama V yetu sasa, kama y yetu ni V, ina act kama y yetu, then mwachana tutapata I ina act kama x yetu plus, so ni ile tu formula sasa. Saizi hii formula ndo sasa nafanya nini? Nafanya sasa reciprocal. Sasa hivi naleta hii side, then what ile kitu nabakisha nini sasa? Hii IR naleta hii side sasa, pia IR naleta hii side, then hii napeleka hiyo side, so it will be negative R, RI plus E, so inakuja hivi. So najileta tu, ni kitu tu najileta, hata kwa mtihani ni kitu tu najileta, because the voltage is the y-intercept and the gradient slope is the resistance. So that is how to determine the voltage. So sometimes unaweza leta kwa practical, sometimes unaweza leta kwa normal paper 2, because this is a paper 2 question. Unajua uzuri ya physics kama it's not like other sciences. It's not like other sciences. It has a specific part for topic for paper 1, a specific topic for paper 2. So if it is, if you have any question, let me know it.